Troubleshooting computer networks can seem daunting, but it's a systematic process that anyone can learn with the right guidance. By following a logical approach, you can identify and resolve most network issues efficiently and effectively. This guide will equip you with the essential knowledge and practical steps to become a confident network troubleshooter capable of handling various scenarios. We'll cover both wired and wireless networks, starting with the basics and progressing to more advanced techniques, ensuring a comprehensive understanding. Network problems can manifest in many ways: slow internet speeds, dropped connections, inability to connect to devices, or intermittent connectivity that disrupts your workflow. Understanding the root cause is crucial for effective troubleshooting, as it allows you to address the issue at its source. We'll delve into common problem areas and provide clear steps to diagnose and fix them, making the process straightforward. This guide is designed for both beginners and those with some networking experience, offering valuable insights for all skill levels. Whether you're a home user or manage a small office network, the principles and techniques discussed here will prove invaluable in maintaining a stable network. Let's get started on your journey to mastering network troubleshooting and ensure your networks run smoothly and efficiently.
Before diving into troubleshooting, it's important to familiarize yourself with the basic components of a network. These components work together to enable communication between devices. Your gateway to the internet, usually provided by your internet service provider, is the modem. The router connects multiple devices and directs traffic between them and the internet. The switch connects devices within a local network, allowing them to communicate. An access point extends a wired network wirelessly, allowing Wi-Fi devices to connect. Cabling, such as Ethernet cables, is used to physically connect devices in a wired network. The network interface card, often integrated into motherboards, allows devices to connect to a network. And finally, a firewall is a security system that monitors and controls incoming and outgoing network traffic. Understanding the role of each component is crucial for identifying the source of a network problem.
The Open Systems Interconnection, or OSI model, is a conceptual framework that divides network communication into 7 distinct layers. Each layer serves a unique purpose and plays a crucial role in the overall process of data transmission. Each layer has a specific function and interacts with the layers above and below it, creating a seamless flow of data. While you don't need to be a networking expert, understanding the basic layers can be incredibly helpful in troubleshooting network issues and ensuring smooth communication. The physical layer deals with the physical transmission of data over the network cable or wireless signals. This includes the hardware components like cables, switches, and routers. The data link layer provides error-free transmission of data frames over the physical layer. It ensures that data is formatted correctly and checks for errors. The network layer handles the addressing and routing of data packets between networks. It determines the best path for data to travel from source to destination. The transport layer provides reliable end-to-end communication between devices, ensuring that data is delivered accurately and in the correct sequence. And the application layer is where applications access network services, enabling software to communicate over the network. Thinking in terms of layers can help you isolate problems more effectively and understand where issues may be occurring. For example, if you can't physically connect to a network, the issue likely lies within the physical or data link layers. Identifying the correct layer can save time and effort in resolving network problems.
The first and most crucial step in troubleshooting is identifying the problem accurately. This involves gathering information and asking the right questions. What is the specific issue? Is it slow internet, inability to connect to a specific website, or something else? When did the problem start? Knowing if any recent changes were made to the network can be helpful. What devices are affected? Is it a single device, or are multiple devices experiencing problems? What error messages are you seeing? Note down any error messages displayed on your devices. Gathering as much information as possible will give you valuable clues and help you narrow down the potential causes of the problem.
Section 5. Physical connection checks. Once you have a clear understanding of the problem, the next step is to check the physical connections. It's always best to start with the basics, as loose or disconnected cables are common culprits. Check all cables. Ensure that all network cables are securely plugged into the correct ports on your modem, router, computers, and other devices. Inspect cables for damage. Look for any cuts, bends, or frays in the cables. Damaged cables can cause connectivity issues. Verify power connections. Confirm that all network devices are powered on and receiving power. Check power adapters and surge protectors. Try different cables. If you suspect the cable might be faulty, try replacing it with a known working cable. Addressing any physical connection issues you find can often resolve the problem quickly.
Section 6. Device configuration and IP addresses. If the physical connections are intact, the next step is to check the configuration of your network devices. This is crucial to ensure that all devices can communicate effectively. This includes verifying IP addresses and other network settings. Check IP address settings to ensure they are correctly configured. Each device on your network needs a unique IP address to communicate. Without unique IP addresses, devices will not be able to send or receive data properly. Ensure that your devices are obtaining IP addresses automatically using DHCP or have valid static IP addresses. Verify router settings to avoid any misconfigurations. Log into your router's web interface and check that the settings are correct. This step is essential for maintaining network stability. This includes your internet connection type, Wi-Fi password, and any security settings. Proper security settings help protect your network from unauthorized access. Look for IP address conflicts. These conflicts can cause significant connectivity issues. Two devices on the same network cannot have the same IP address. This will lead to communication errors. If you suspect a conflict, release and renew the IP addresses on the affected devices. This can often resolve the issue quickly. Disable and re-enable network adapters. This can refresh the network connection. Sometimes, simply restarting your network adapters can resolve connectivity issues. This is a simple yet effective troubleshooting step. Proper device configuration is essential for a smoothly functioning network. Ensuring all settings are correct will help maintain a stable and efficient network environment. Section 7. Testing network connectivity. Once you've checked the physical connections and device configurations, it's time to test network connectivity using diagnostic tools. Ping, a command line tool that sends packets of data to another device on the network to check if it's reachable. Traceroute, a tool that traces the route that packets take from your device to a destination device, helping you identify bottlenecks or network outages. By using Ping and Traceroute, you can gain insights into the flow of data on your network and pinpoint areas of concern.
Section 8. Troubleshooting wireless networks. Troubleshooting wireless networks presents its own set of challenges. Here are some common issues and how to address them. Ensure that your devices are within range of the Wi-Fi signal. Weak signals can cause slow speeds and intermittent connectivity. Overlapping Wi-Fi channels can cause interference. Try changing the channel on your router to one that is less congested. Wireless signals can be affected by physical obstacles and interference from other electronic devices. Try relocating your router or devices to minimize interference. Wireless troubleshooting often involves trial and error to find the optimal configuration.
Section 9. Advanced troubleshooting techniques. If the basic troubleshooting steps haven't resolved the issue, you might need to delve into more advanced techniques. Your operating system and network devices keep logs that can provide valuable information about errors and events. Routing tables determine how data packets are forwarded on a network. Checking routing tables can help identify routing issues. If you're using virtual LANs or VLANs, ensure that they are configured correctly on your switches and devices. Outdated firmware can cause compatibility issues and security vulnerabilities. Keeping your network device's firmware up to date is crucial. These advanced techniques require a deeper understanding of networking concepts.
Section 10. Documentation and record keeping. Throughout the troubleshooting process, it's crucial to document your steps and findings. This documentation can be invaluable for future troubleshooting efforts or for escalating the issue to more experienced technicians. clearly describe the problem you're experiencing. List the steps you've taken to try and resolve the issue. Keep track of any configuration changes or modifications made to the network. Note down any error messages encountered, as they can provide valuable clues. Proper documentation helps you track your progress and avoid repeating unnecessary steps. Section 11. Preventive measures and best practices. While troubleshooting is essential, taking preventive measures can help minimize network problems in the first place. Schedule regular checks of your network equipment, cables, and configurations. Implement network monitoring tools to proactively identify and address potential issues before they escalate. Educate network users about best practices for network security and usage. Have backup plans in place for critical network components to minimize downtime in case of failures. By following these preventive measures, you can create a more stable and reliable network environment.